Hey, welcome students. This is Mr. Brinton for our first video vodcast where we'll be taking our notes for class and for studying purposes. Don't forget, you should be having your spiral notebook, getting your notes in there so they stay in one place. Hopefully these videos won't take too long, 5-10 minutes maybe. Don't forget they will be your homework assignment, so in replace of some of these other things, we're going to be taking our notes with trying to do most of our notes at home, and we'll see what we can do in class. So let's get started. So what you need to know, a couple of things here. Let me just see if we can move this out of the way here. Is some basic vocabulary for our scientific method. We call this scientific experimentation, scientific observations and theories, things like that. We'll be taking a few more notes throughout the days to get our scientific method, graphing, experiments all done. So don't forget, you do need to write these down. You can pause the video at any time. You can go back, rewind it, go at your own pace. So that's the idea here. So, all right. So anyway, observations, we know, seen or measured, and they're through our five senses, through instruments. We'll get into using some different instruments that we can measure with later on, but basically from our five senses. Inferences, they're the next idea here when we come to experiments, and we say conclusions based on observations. Basically, we're making sense out of the world. You're taking these observations down, trying to make some sense out of that to figure out what's going on. Okay, next, let's see if we can bring this up a little bit. We've all done hypotheses in middle school before, and remember they're prediction for something that's going to be happening in our experiment. Testable prediction that some of your middle school teachers mentioned, and the idea that hypotheses can be falsified if it's not testable and there's no way that it can be falsified or proven false. Doesn't mean to say that it is false, but if it cannot be set up to where you can test this to see if it is false, then we don't consider it a scientific experiment. We don't consider it hypothesis. We're going to be getting into setting up our plant experiment. So one of our examples could be that we're working with fertilizer, adding different amounts of fertilizer. So you want to make a prediction, and you might say fertilizer will increase the plant growth. Well, you haven't done that experiment yet. It can be easily set up so that you can see whether that's false or not. So we can consider that our hypothesis. All right. The last thing we'll get in today, and this is the last thing that we have to write about, are theories, and the idea that theories are explanations of natural events. Also the idea that they're supported by strong evidence, that we don't just guess at certain things or randomly take little bits of information from here or there and just take information that we want, but we look at all the evidence that we have currently to date for our theory. Evidence is gathered by many scientists. We tie in a lot of different things: facts, hypotheses, laws, theories. The other thing is that theories are not opinions. A lot of people think, well, it's just this person's opinion or that person's opinion. No, it is based on quite a bit of information. The other thing that we definitely want to focus in on high school, and you're going to get tested on with the regents a lot, is that all theories are subject to change, because we have to assume that we don't have all the evidence to date, and if new evidence is found, then we have to be willing to go back and look at these theories and add to it or change that theory based on the evidence that we have, not just what people want them to be. So we've heard of a lot of different theories out there. We're going to be talking about the theory of natural selection by Charles Darwin. There's cell theory. There's the atomic theory. And we can't see all these things Some of them we can start to see, but since we don't see everything, we need to come up with the best theories that we have based on the evidence that we have, and be willing to discover new evidence and modify or change that theory. We're not modifying it based on what we want it to be, but we're modifying it on the evidence that we have to date. Okay, so that is where we're going to wind up with our notes. You don't have to take any more notes for tonight, so that wasn't too long. Hopefully you have them all in your notebook. We'll see how you guys do. Show them to me next time we have class, because this is your homework. But here's a current Regents question here. It says the current knowledge concerning cells is the result of investigations and observations of many scientists. The work of these scientists forms a well-accepted body of knowledge about cells. This body of knowledge is an example of, and you can see that what we've talked about here, you're already thinking already, I think, that it's C. It's a theory, and because we know that it's based on the knowledge, the body knowledge that we already have, and that we have, it's the investigation part, but it's through many scientists, well accepted. That all makes that a theory. Okay. All right. So that concludes what we want to talk about today. Don't forget, bring your notebook to class so that we can use it in class. I'll be checking them, counting those as homeworks. Since we're trying to supplement the homework, the notes with the homework, and maybe do some of the difficult homework in class, and where we can help out a little bit more. So get these notes down, and we'll see you in class. All right. Talk to you later.